Hello everybody, and today we can finally start with the C++ basics chapter with the 1.1. And before we start, I quickly want to say again that this website learncpp.com is free for use and is ad sponsored. So if you want to learn on this page, please put out your ad blocker so it can be maintained for a much longer time. And as you can see, I have the ads off because I'm making the video, but for you that does not post any content and does not want to have commercials in your video, please enable the ads and this website can be sponsored for him and for people that look for this website, and you can look it at support or and contact. And let's start with it. 1.1 Statements and structure of a program. And here, statements of a structure and structure of a program, chapter introduction. Welcome to the first primary chapter of these C++ tutorials. In this chapter, we will take a first look at a number of topics that are essential to every C++ program because they are quite a few topics to cover. We will cover most at a fairly shallow level, just enough to get by. The goal of this chapter is to help you understand how basic C++ programs are constructed. By the end of the chapter, you will be able to write your own simple program. In future chapters, we will revisit the majority of these topics and explore them in more detail. We will also introduce new concepts that will build on top of these. In order to keep the lesson's length manageable, topics may be split over several subsequent lessons. If you feel like some important concept isn't covered in a lesson, it's possible that it's covered in the next lesson. To the statements. A computer program is a sequence of instructions that tells the computer what to do. A statement is a type of instruction that causes the program to perform some action. Statements are by far the most common type of instruction in a C++ program. This is because they are the smallest independent unit of computation in the C++ language. In that regard, they act much like sentences do in natural language. When we want to convey an idea to another person, we typically write or speak in sentences, not in random words or syllables. In C++, when we want to have our program to do something, we typically write statements. Most, build not all, but not all, statements in C++ end in a semicolon. If you see a line that ends in a semicolon, it's probably a statement. In a high-level language such as C++, a single statement may compile into many machine language instructions. There are many different kinds of statements in C++. Declaration statements, jump statements, expression statements, compound statements, selection statements, conditionals, iteration statements, loops, try blocks. By the time you're through with these tutorial series, you will understand what all of these are. And now to functions and the main function. In C++, statements are typically grouped in units called functions. A function is a collection of statements that get executed sequentially in order from top to bottom. As you learn to write your own program, you will be able to create your own function and mix and match statements in a way you please. We will show how in a future lesson. Rules, or a rule. Every C++ program must have a specific function named main. All lowercase letters when the program is run. The statements inside of main are executed in sequential order from top to bottom. And programs typically terminate finish running after the last statement inside a function, in the main function. The main has been executed through programs may abort easily in some circumstances or do some cleanup afterwards. Functions are typically written to do a specific job or perform some useful action. For example, a function named max might contain statements that figures out which two numbers is larger. A function named calculate grade might calculate a student's grade from a set of test scores. A function named print employee might print an employee's information to the console. We will talk a lot more about functions soon, as they are the most commonly used organizing tool in a program. Nomenclature. When discussing functions, it's fairly common shorthand to append a pair of parentheses to the end of the functions. Name, for example, if you see the term main parenthesis or do something parenthesis, this is shorthand for functions named main or do something respectively. This helps differentiate functions from other things with names, such as variables, without having to write the word function each time. In programming, the name of a function or object type, template, etc. is called its identifier. Dissecting Hello World. Now that you have a brief understanding of what statements and functions are, let's return to our Hello World program and take a high-level look at what each line does in more detail. Here we have the normal Hello World program, and now we go through each line. Line 1. It's a special type of line called preprocessor directive. This preprocessor directive indicates that we would like to use the content of the IO stream library, which is the part of the C++ standard library that allows us to read and write text from the console. We need this line in order to use stcout on line 5. And including this line would result in a compile error. Excluding this line would result in a compile error on line 5, as the compiler wouldn't otherwise know what stcout is or cout. Line 2 is blank and is ignored by the compiler. This line exists only to help make the program more readable to humans by separating the hashtag include preprocessor directive and the subsequential parts of the program. Line 3, the int main tells the compiler what we are going to write. Define a function whose name identifier is main. As you learned above, every C++ program must have a main function or it will fail to link. Line 4 and 7 tells the compiler which line are part of the main function. Everything between the opening curly brace on line 4 and the closing curly brace on line 7 is considered part of the main function. This is called the function body. As you can see here, everything in between these brackets, and this is the stcout and the return 0, this is run by the main function because it's inside them. And now we go to line 5, is the first statement with the function main, and it is the first statement that will be executed when we run our program. stcout, which stands for character output, and the double smaller than operator allows us to display information on the console. In this case, we're displaying the text hello world. This statement creates the visible output of the program. Here, as you can see, simply that. And then never forget, if you start new with programming, the semicolon. And line 6 is a return statement. When an executable program finishes running, the program sends a value back to the operating system in order to indicate whether it ran successfully or not. This particular return statement returns the value 0 to the operating system, which means everything went okay. This is the last statement in a program that executes. All of the programs we write will follow this general template or a variation of it. An author's note: if parts or all of the above explanation are confusing, that's to be expected at this point. This was just to provide a quick overview. Subsequent lesson will dig into all of the above topics with plenty of additional explanation and examples. You can compile and run this program yourself, and you will see that it outputs the following to the console: hello world. If you run into issues compiling or executing this program, check out lesson 0.8, a few common C++ problems. And I have opened my Visual Studio program with exactly that, and we can make it look the same. And when we run it, it outputs us our hello world. We have started it with debugging right now. We can also run it without debugging. In this way, it's a bit faster. And then we are getting the hello world, our directory folder, and then the command if we want to press something that it would end the console. And with that we can go back. And syntax errors. In English, sentences are constructed according to specific grammatical rules that you probably learned in English class in school. For example, Norman sentences end in a period. The rules that govern how sentences are constructed in a language is called syntax. If you forget the period and run two sentences together, this is violation of the English language syntax. C++ has a syntax too. Rules about how your program must be constructed in order to be considered valid. When you compile your program, the compiler is responsible for making sure your program follows the basic syntax of the C++ language. If you violate a rule, the compiler will complain when you try to compile your program and issue you a syntax error. Let's see what happens if we omit the semicolon on line 5 of the hello world program like this. And feel free to compile this ill-formed program yourself. We can try this, and we go to our hello world program and we put away our semicolon right here. And now we try to run it. We run it first without a debugger, and then it says it doesn't work, and directly an error comes, and then expected a semicolon, and it even says us on line 6. And you might think, our line is where the semicolon is missing is on line 5, but you have to see how the computer works. And here return is a new command, and the computer reads it like this, like the return would be on line 5, and directly after that it will say that. And this is why he says it's on line 6. When we have it like that, it will say it's on line 5, the error. And we can try that, and we see, the error is on line 5. We have some more issues here because it's in one row right now, but we can separate that again, and we have no issues anymore, and we replace our semicolon and everything is fine again. So this is that, and we can continue. And Visual Studio produces the following error. Your compiler may generate an error message with different wording. And this is telling you that you have a syntax error on line 6. The compiler was expecting a semicolon before the return statement, but it didn't find one. Although the compiler will tell you which line of code it was compiling when it encountered the syntax error, the omission may actually be on a previous line. In this case, the error is actually at the end of line 5. The compiler didn't discover the issue until line 6. That's what I tried to show you before. And the syntax errors are common when writing a program. Fortunately, they're typically straightforward to find and fix, as the compiler will generally point you right at them. Compilation of a program will only complete once all syntax errors are resolved. You can try deleting characters or even whole lines from the Hello World program to see different kinds of errors that get generated. Try restoring the missing semicolon at the end of line 5 and then deleting lines 1, 3 or 4 and see what happens. Quiz time. The following quiz is meant to reinforce your understanding of the material presented above. What is a statement? Like we had before, I haven't showed into the solutions before, so I answered them before and look if I have them right. I will do that for every single one. And a statement, as I got it, is the path I can show you in the program. For example, the statement, the std out hello world until our semicolon is a statement. And I will just say it like that until your next semicolon. All those are statements, and for example, return to 0 is also a statement for itself. And let's see what our solution to it is. A statement is an instruction in a computer program that tells the computer to perform an action. That's a very general explanation of it. Yeah, but it is a statement is basically for everything that we instruct the computer. It's some statement like you have in the normal English language. If you say this is a watch, for example, this is a statement by itself, and the computer reads the same just in a computer language. And now we go further. What is a function? Function is a folder, or it's the function, and it contains all the statements. It's basically a library of statements that we program. And let's see what it says. A function is a collection of statements that executes sequentially. That's maybe important, that executes sequentially, because when you have a function, it goes always from top to bottom. And I think that is meant by sequentially. And what is the name of the function that all programs must have? It's the int main function. And yes, it says main function. And maybe you could change the int main, but until now I haven't noticed any other than int main functions in any program. So before the main, it's normally int main, like you see here, because this is an integer main, because the main function always ends by the return 0, and this is just a 0 that will be returned, so it is an integer, and this is the main function. And the next one is question 4. When a program is run, where does execution start? Execution starts from top to bottom, and then the next one will be the int main after the libraries. For example, here first you have to include all the libraries, but the program does not start here, because libraries are only used if you have your statement that uses the library or the include. And for that, the program starts, or the compiler starts at the beginning of the main function and looks what you want to do. And let's see what it says. Execution starts with the first statement inside the main function. Yes, exactly, we were right. And what symbol are statements in C++ often ended with? That is the semicolon. And then the next one, what is a syntax error? When you have written something wrong that is meant to be different, like the English language, the programming language has the same rules of following characters that have to be in the correct order. And let's see what it says. A syntax error is a compiler error that occurs at compile time when your program violates the grammar rules of the C++ language. Correct. And what is C++ standard library? This is basically what we see here. The hashtag include IOStream, that's the standard library from C++, and those are some commands included the stdout for our hello world program in it. And let's see if we show a hint review lesson. Okay, show the solution. A library file is a collection of precompiled code that has been packed up for reuse in reuse in other programs. The C++ standard library is a library that ships with C++. It contains additional functionality to use in your programs. Yes. And one functionality, like I said before, is this stdout, and there are many more, and we could look theoretically in what in this library all is, but for now this is not what we want to do. What we want to do is continue to our next lesson, and this is the lesson 1.2, comments. And here we have the comment. A comment is a programmer readable note that is inserted directly into the source code of the program. Comments are ignored by the compiler and are for the programmer's use only. In C++, there are two different styles of comments, both of which serve the same purpose: to help programmers document the code in some way. Single line comments. The double slash symbol begins a C++ single line comment which tells the compiler to ignore everything from the double slash symbol to the end of the line. For example, stdout hello world, and then we make the double slash, and everything from here at the end of the line is ignored. Typically, the single line comment is used to make a quick comment about a single line of code. And you can do that for if you have more couts or character outs, you can do that behind each of the lines, and it does not impact your code at all. Having comments to the right of a line can make both the code and the comments hard to read, particularly if the line is long. If the lines are fairly short, the comments can simply be aligned, usually to a tab stop, like so. And then there are perfectly aligned and very good to read. And like it says, as the code lives in the IOStream library, this is much easier to read, don't you think so? And yeah, however, if the lines are long, placing comments to the right can make your lines really long. In that case, single line comments are often placed above the line it is commenting. And yeah, like this example here. And we can basically experiment that in our own program. Here we can make a double slash and say something hello, for example, and when we run our program it will not impact it at all. You will not see anything about this hello that I have just written. And for the example, you can make just some slashes and here as well, so there are lines correctly, and then you can hello hello Bob, yes, I like Bob, and then you have hello Bob perfectly aligned on both sides, and then you can delete them again. And for example, if you make a double slash at the beginning of something on the left side, for example, you make a double slash here before your stdc out from hello world, and you can see now it is all a comment, and when we want to run our debugger, it will output nothing at all because we have nothing in it because we commented our line now. This is commonly used if you have something in your program that you want that it does not run at the moment. Just make a double slash at the beginning of it and it will not run at all. And that's practical in some sense, that it makes it so it ignores it. And you have to watch out for something like that, or you can do your comments everywhere, and this is a single line comment, so it will not impact your next line when you make a double slash. And with that we can go further in our Learn CPP. Author's note. The statements before represent one of our first encounters with snippets of code because snippets aren't full programs. They aren't able to be compiled by themselves. Rather, they exist to demonstrate specific concepts in a concise manner. If you would like to compile a snippet, you will need to turn it into a full program in order for it to compile. Typically, that program will look something like this. Then slash slash, replace this line with the snippet of code you would like to compile. And then you make this comment here, and you know you want to write afterwards something in it, but you have just made a notice here that you know, yes, I have to do that, that you will not forget it and have just a program that is not finished and you don't know where to place the code when you have an error. And this is very good that you have that. This, for example, if we don't have this statement here right now, or we want to have another statement, you can write here double slash, we need an introduction, then or you can just write introduction here, for example, and then you know I want to later make my introduction here, and then you have a comment here and you know your introduction will be there. And if not, you can simply change that comment to another place in your program and make it then there. But you have to comment and you know that you want to do it, and that's a good trick to not forgetting stuff in your code. And now multi-line comments. The slash multiplication sign or star and star slash pair of symbols denotes a C-line multi-line comment. Everything in between symbols is ignored. So like this example here, you have to make one at the start, one at the end, and until you have not made an end, it will be a comment. Since everything between the symbols is ignored, you will sometimes see programmers beautify their multiple line comments. Yes, and they make stars on the side, so yeah, it's just a visual aspect of it. And multi-line style comments cannot be nested. Consequently, the following will have unexpected results. And we could try this as well. We could even try it right now. For example, we make a multi-line comment here and we open it, and it directly makes the end of the multi-line. And for example, if we put it here, all of our code will be commented. Doesn't matter how many lines it will be. Even the curly brackets will be commented. Everything, if it's between them. And as he said, you can write something in here and it runs normally, but he said when we want to make a new one, for example, again with that, let's see if this causes us an error. No, it does not, because yeah, of course, because it's in our comment, and as long as it's in the comment, it doesn't bother the problem at all. And I can look at the example that he has. This is not inside comment. Yes, I know how he did that. Yes, for example, here the comment ended, and now you can write normally, and this one impacts the code. And when you make a single line comment here now, or you want to start a new, or you want to end the comment again and make it like this, it will not work. All the code that is written after that will be executed as well. For example, if we copy that quickly and paste it in here, and this will be run because this comment will not be executed. You can only end it once. You would have to start it again here, and only after you have started it, it knows, you want to comment that, and it generates us the end as well, but we don't want that. Only if you start it again and end it, it will actually be commented. And with that, we can delete that again and have our normal hello world program. And we go back and read along. When the compiler tries to compile this, it will ignore everything from the first /* to the first // since this is not inside the comment. Is not considered part of the comment. The compiler will try to compile it. That will inevitably result in a compile error. But it should be not a problem, because you see if it's comment, it's green even in my program, and if it's not green, you know it's not in the comment. But if you make it always like the examples he showed first, you will not even have to bother about this problem at all when you make a comment. This is one place where using syntax highlighter can be really useful, as different coloring comments should make clear what considered part of the comment versus is not. Yes, if you have no coloring in your IDE, it could be a little bit more difficult to figure this out when it's not commented, but normally when you do it in this specific rule, like he showed us, this will not occur. And a warning: don't use multi-line comments inside other multi-line comments. Wrapping single line comments inside multi-line comments is okay. Wrapping single line comments inside multi-line comments is okay. Yeah, just don't use multi-line comments in multi-line comments. This could cause some errors like here. And that's that. And then we come to the proper use of comments. Typically, comments should be used for three things. First, for a given library program or function, comments are best used to describe what the library, program, or function does. They are typically placed at the top of the file or library, or immediately representing the function, for example. This program calculates the student's final grade based on their test at homework scores. This is just an example what a comment could look like. And then this function uses Newton's method to approximate the root of a given equation, so we know exactly what the program does when we have a comment above it. And the next one he did is the following lines generate random items based on rarity, level, and weight factors. And back to the text, all of these comments give the reader a good idea of what the library program or function is trying to accomplish with having to look at the actual without having to look at the actual code. The user possibility someone else or you if you're trying to reuse your code you've previously written can tell at a glance whether the code is relevant to what he or she is trying to accomplish. This is particularly important when working as part of a team, where not everybody will be familiar with all of the code. Second, within a library, program, or function described above, comments can be used to describe how the code is going to accomplish its goal. Now we have a multi-comment. To calculate the final grade, we sum all the weighted. Yes, this is how the function works. And then to generate a random item, we are going to do the following: put all of the items of the desired rarity, and then it goes through the list what our program does, and then you know it. First, it has a specific explanation of the program and then an explanation what it exactly does. And these comments give the user an idea of how the code is going to accomplish its goal without having to understand what each individual line of code does. And this can be very useful. It makes you much faster because you don't have to go each time through your code to understand it, and you can just read the comments and hover over it and you know exactly what you have to do. Third, at the statement level, comments should be used to describe why the code is doing something. A bad statement comment explains what the code is doing. If you ever write code that is so complex that needs a comment to explain what a statement is doing, you probably need to rewrite your statement, not comment it. Here are some examples of bad line comments and good statement comments. Bad comment: set site range to 0. Yes, that basically says what the code that you have written does. So it brings you exactly nothing at all. Reason: we already can see the site is being set to 0 by looking at the statement, and you don't have to say that in the comment. Good comment: the player just drank a potion of blindness and cannot see anything. Reason: now we know why the player site is being set to 0. And this is a good comment because it says what it impacts and why it is on the value that it has, and it's 0 because the blindness. And a bad comment would be calculate the cost of the items, and yeah, quality times 2 times store piece. Yeah, you see there is something that will be calculated, but you have no clue what it is that is calculated. We can see that is cost calculation, but why is quality multiplied by 2? No idea. The good comment would be we need to multiply quality by 2 here because they are both in pairs. And then you know, yes, they are pairs, and because they are pairs, you want to multiply them by 2. So perfect. So because you have 2 of them, multiply both by 2 and perfect. Reason: now we know why this formula makes sense. Programmers often have to make a tough decision between solving a problem one way or solving another way. Comments are a great way to remind yourself or tell somebody else the reason you made one decision instead of another. Good comments: we decided to use a linked list instead of an array because arrays do insertion too slowly. And then you know exactly why he has chosen a certain way to program his program instead of the other. That could be more easy, but will not have the requirements for his program. And another good comment is, we are going to use Newton's method to find the root of a number because there is no deterministic way to solve this equation. And with that, you also know exactly why he did something in that exact way. Finally, comments should be written in a way that makes sense to someone who has no idea what the code does. It is often the case that programmers will say, it's obvious what this does. There's no way I'll forget about this. Guess what? It's not obvious. And you will be amazed how quickly you forget. You or someone else will thank you later for writing down the what, how, and why of your code is human language. Reading individual lines of code is easy. Understanding what goal they are meant to accomplish is not. So if you use something in a particular way on purpose, just write a comment why you have done this way, and you know why it's this way, and everybody that reads your code knows it and will not change it just like that. And then related content. We discuss commenting for variable declaration statements in lesson 1.7, keywords and naming identifiers. Best practice. Comment your code library and write your comments as if speaking to someone who has no idea what the code does. Don't assume you will remember why you made a specific choice. For example, write your comment. If you would look in 20 years again on your code, you would exactly remember, or maybe not even remember, but you know what your code will do. So if anybody else would look on your code, he knows also what he would have to do. And also a good example, like Albert Einstein said, explain something that also a 5-year-old could understand it. So this would be the perfect comment if you can do it like that. And throughout the rest of this tutorial series, we will use comments inside code blocks to draw your attention to specific things, your help illustrate how things work, while ensuring the programs will compile. Astute readers will note that by the above standards, most of these comments are horrible. As you read through the rest of the tutorial, keep in mind that the comments are serving an intentional educational purpose, not trying to demonstrate what good comments look like. Commenting out code. Converting one or more lines of code into a comment is called commenting out your code. This provides a convenient way to temporarily exclude parts of your code from being included in your compiled program. To comment out a single line of code, simply use the /style command to turn a line of code into a comment temporarily. Uncommented out, and here we have just stc out that outputs 1, and we can just comment it out, and then it is commented. The comment out and to comment out a block of code, use / on multiple lines of code, or the multi-line style command to turn the block of code into a comment temporarily. And you can comment as if you have multiple lines, you can just set the multi-line comment first at the top and the other at the bottom. There are quite a few reasons you might want to do this, and before I do that, I show you how it is done. I already showed it before. You just have to make this double slash, and then it will comment out. And that's basically all of it, and it will not be run because it's ignored by the compiler. And now the first why there are reasons that you might want to do that. You're working on a new piece of code that won't compile yet, and you need to run the program. The compiler won't let you compile the code if there are compiler errors. Commenting out the code that won't compile will allow the program to compile so you can run it. When you're ready, you can comment the code and continue working on it. So if it really does not work, you can, it's just a easy way out, for example, and you can work. And second, you have written new code that compiles but does not work correctly, and you don't have time to fix it until later. Commenting out the broken code will ensure that broken code does not exclude and cause problems until you can fix it. And 3, to find the source of an error. If program isn't producing the desired result or is crashing, it can sometimes be useful to disable parts of your code to see if you isolate what's causing it to not work correctly. If your comment is one or more lines of code and your program starts working as expected or stops crashing, odds are whatever you last commented out was part of the program. You can then investigate why those lines of code are causing the problem. You can just, if your program is longer, you can just comment out the section, and then you will find the program very fast, or the problem. You want to replace one piece of code with another piece of code instead of just deleting the original code. You can comment it out and leave it there for reference until you are sure your new code works properly. Once you are sure your new code is working, you can remove the old code out, and if you can't get your new code to work, you can always delete the new code and uncomment the old code to revert to what you had before. This is very good if you want to try something new and the previous one works, and as long your new one is not doing as good as the old one, you can still put the old one back into place and delete that what you just tried. And then commenting out code is a common thing to do while developing. So many IDEs provide support for commenting out a highlighted section of code. How you access this functionality varies by IDE. For Visual Studio users, for me, you can comment or uncomment a section via Edit menu, Advanced Comment section, or Uncomment section. And we can quickly look at that. Edit menu, Advanced, and then Comment selection. Let's try. Edit menu. Wait, maybe. No. Edit menu. Where could be? Here we have via edit menu. Maybe it's not here. We have here tools. Maybe it's here, edit menu. Maybe it's described where you can uncomment a selection by via edit menu, Advanced. We could type in search for edit menu. Edit menu. Let's see if there is one. Not really. In the edit menu and then Advanced. Edit menu. here on advanced and then comment section. Yes, and yeah, it what it does, it basically makes a comment, and maybe if we uh, make all selected and we go to that view that we just had to advanced and then comment section, then it comments all of that and you don't have to make all the single line comments by yourself. So yes, it can be practical if you want to do that. That's how that works. And then to a tip, if you always use single line comments for your normal comments, when you can always then you can if you always use single line comments for your normal comments, then you can always use multi-line comments to comment out your code without conflict. If you use multi-line comments to document your code, then commenting out code using comments can be more challenging. If you do need to comment out a code block that contains multi-line comments, you can also consider using the /if0 preprocessor directive, which we discuss in lesson 2.10, Introduction to the Preprocessor. Probably it's a directive or a library for commenting that the whole file will be commented. But that's not for now. That will be in the 2.10 instruction to the preprocessor and not now. And the summary: at the library program or function level, use comments to describe what. At the library program for function level, use comments to describe what, how the function works, that everybody that looks at it knows directly what it does. And inside the library program or function, use comments to describe how at this state and how what it does, how it does it, by setting something to 0 or to whatever how you have in your code. At the statement level, use comments to describe why it uses that. And then we have our next lesson and we go to instruction to objects and variables. But that part we look into in the next episode, and I hope you enjoyed it or learned something watching it. And with that, that's the end of the video, and I say bye.